Hey guys, so welcome to our first lesson using YouTube and this kind of video site that I am working on. Okay, so we're going to continue with finding domain and range of functions. Today we're going to focus on given the equation. So I want you to pause the video and try the do now. Again, this is another SAT question. So you could use synthetic or long division. I think long division is just easier because the denominator has a fraction. Plus this is pretty small. So 4x goes into 4x squared x times 4x squared plus 2x. Change the sign of the bottom. And we get 4x. 4x goes into 4x once. So 4x plus 2. Change the sign. So my remainder is -2. So that means my answer is D. So yeah, so the ones that we did in class were significantly harder than this one. All right, so pause the video and write down what's the domain and range of this. So the domain is remember that's your x's. So the smallest x, notice this is getting really, really close to the x-axis, so it doesn't ever touch it. So I'm going to say that from farthest left, it's 0. It doesn't actually get to 0, so it's going to be curved, comma. We have that that arrow. A lot of the graphs, for some reason, don't put an arrow there. And then the range, this is going down, down, down forever, so that's -infinity. And then up. This is pretty flat. We're actually going to talk about this specific function later on in the year. But it is going up, so it's infinity to -infinity to infinity, or all real numbers. Or you could actually write out, if you want, all real numbers. All right, so all three of those answers is correct. Okay, domain and range. So we're going to focus on almost all the problems we're going to be given today are things that we know what they are. So really think about, what is this a graph of? So pause the video, see if you can think about what these graphs are and what the domain and range would be. So number 1, y equals 3x minus 12, that's just a line, right? So there's my line. So the domain, -infinity to infinity, range, -infinity to infinity. Done. Number 2, an absolute value. So if I were to graph this, it's got a vertex of -5, -2, and it's a v, right? So what's the domain of an absolute value? What are you able to plug into that function? Well, I can plug in -1 billion, I can plug in 1 billion. The domain is just all real numbers. The range, on the other hand, what is the lowest this thing goes? -2. Now it does actually equal -2. So -2 to infinity. Number 3. I'm going to move this up a bit. All right, so we spent some time graphing this, and this is why I moved this unit so that you knew what this looked like. So if I were to graph that absolute value, the square root, its starting point is 2, 1. And it just looks like that. So the domain is 2 to infinity, right? Farthest left, farthest right. The range, the lowest point is right here, 1. The biggest point is an arrow, so 1 to infinity. Another way of thinking about the domain here, we're only dealing with real numbers. You can't have a negative under the square root, so it's really just, when is x minus 2 greater than 0? X is greater than 2, which is just the inequality that goes with this. Okay, so that's the other way to think about it. All right, y equals 7. So this is one that throws kids off. Think about what the graph looks like. y equals 7 is just a horizontal line through 7. What is the domain? Well, every x value has a y value, right? If I'm here, then I'm there. If I'm here, I'm up there. Over here, I can always plug, even though there's no x to plug in, it's still all real numbers. What's the range? What is the only y value we can get out of that? No matter what we plug in, we always just get 7. And we're done. All right, again, this is why I moved this unit, because I wanted you to know what these graphs looked like. All right, so think about an x cubed. What does that look like? Right, something like that. Doesn't really matter. So this is all real numbers. You can plug anything in there you want. All real numbers, right? Because the arrows are going in opposite directions, you can get anything. Now, number 6 is a little different. This one is a parabola. Something like that. It's upward facing. So the domain is the easy part. The domain is just all real numbers. I can plug in a billion, I can plug in negative billion. So, but the range, on the other hand, is something we have to actually figure out. This graph is never going below that point. We're never hitting y values down there. So that means we have to figure out the y value right here. So what is that thing? It's our vertex, so negative b over 2a. Or you complete the square, it actually doesn't matter. So if I do negative b over 2a, negative 8 over 2 is negative 4. So this point is negative 4, comma, but we need the y value. So we're going to plug in y of negative 4 equals 16 minus 32 minus 11. Negative 16 minus 11 is negative 27. So it's negative 27 to infinity. So with parabolas and even number exponents, we have to find that vertex to find the range. All right, last one. So now number 8, pause the video. Do number 8 and number 9. Number 7 is something we've never done before. So now we have to use our brains. Think about a fraction. What can you never have when you have a fraction? You are never able to let the denominator equal 0. So x minus 3 cannot equal 0. X cannot equal 3. So the domain is all real numbers except x equals 3. Not except x doesn't equal 3, that's a double negative. So the except is our not. Okay. Now, the range is a little more challenging. So if I set this equal to something, what can I never get out of this, right? Could I get a half? If I set this equal to a half, could I solve? So here, I'm just going to tell you, can you ever get this to equal 0? Will that ever equal 0? If I plug in 1,000, if I plug in 1,000,000,000, we get really close to 0, but we never reach it. So that's the one that we want to kind of focus on, and we're gonna come up with a good rule for this. But when you have a fraction where there's nothing in the numerator, it's just a constant. When that's a constant and you have x's in the denominator, typically it's all real numbers except y equals 0, because no matter what we plug into that fraction, it's never going to work. It'll never get us to 0. All right, so the number 8 and 9 you should have been able to figure out, right? Oops. Domain first and then range. So what's the domain? What can you not plug in to a cubed root? Well, if we plotted this, right? Negative 7. Is there anything you can't plug into that? Nope. All real numbers. all real numbers. So we didn't do a lot of graphing of these. So we want to use that idea of what we just talked about. When will this be greater than 0? We need that inside to be greater than 0. So that means 5 is greater than 2x. X is smaller than 5 over 2. So if x is less than 5 over 2, that means 5 over 2 is the biggest number we can have. And the smallest is negative infinity, right? I can plug in negative a billion. Those double negatives will end up making it positive. That's our domain. And then what's the range? Our starting point for this is 5 over 2. Is this graph going up or down when you graph it? So 5 over 2, it's going up. It's actually going to the left, though. Just kidding. Right? So that negative on the inside makes this thing go like that. So the y value, the smallest y value is 0, but then it goes up forever. So 0 to infinity. All right, pause the video. Try number 10. It's very similar to number 7. So just like before, we can't have 0 in the denominator. So I'm going to set that equal to 0, factor it, x minus 9, x plus 4. Why is my pen working weird? So x equals 9, x equals negative 4. That is what the graph cannot have, right? If we plug in 9, I'm going to get 1 over 0. That's not allowed. So for the domain, all real numbers except x equals 9 and x equals negative 4. The range, again, no matter what we plug into this, that whole fraction will never equal 0. So it's all real numbers except y equals 0. Okay, and that's it. That is our lesson. So please try the worksheet. I'm gonna have an answer key, and then I'm gonna give you guys time to ask questions, because this is actually the hardest part, what we just did, number 7, number 10. This is the hardest part of domain and range. So I'm going to give you time to practice that and ask questions during our group chat on Wednesday. I want to say I said Wednesday. I can't remember. I have to check the schedule. All right. Email me if you have questions. Have a fabulous day, guys. Let me just